Geometry section 3.1, part 1. Just going to begin talking about parallel lines. As you look at the first picture here, now we don't know that these lines are parallel. On the next slide, we will be defining the lines as parallel. They look parallel, but you can't assume that they are unless you're told that they are. We need to learn some terms first. Corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles, same side exterior angles. We're going to define each one of these by looking at the picture. The first one, believe it or not, the first one is somewhat the one that seems to get overlooked. So I could put a kind of a spotlight on this first one. Corresponding angles, make sure you know what they are. Basically what they are with respect to their intersection, like this intersection and then this intersection, is angles that are in the same position. So for example, angle 1 and angle 5 would be in the same position. They're both in the upper left. Now these are corresponding angles. Now in doing this, I don't mean to say that they're congruent. We will do that on the next slide when we know that these lines are parallel. We don't know that right now, but I'm just using this marking to show that they are corresponding angles. Okay. If we don't know these are parallel, we don't know these are congruent. I'm just showing that these are corresponding angles. Just the same, angle 2 would be corresponding with angle 6. Angle 4 would be corresponding with angle 8. And angle 3 would correspond with angle 7. Okay, so those are corresponding angles because they are in the same position, if you will, upper right, lower left, whatever. Okay. Next word is alternate interior angles. Now this is named correctly, alternate interior. This line right here is what's known as a transversal, whereas L and M are what I always call the potentially parallel lines, right? We don't know that they're parallel. If we knew that they were, then we just call them the parallel lines. T is a transversal that cuts through both of them. It kind of intersects, if you will, both of them. And alternate interior angles are angles that are on opposite sides of the transversal, interior the parallel lines. Think about the parallel lines where they are. On the interior would be angles 3, 4, 5, and 6. Well, the alternate interior angles, and you can see that they're all listed here as well as I'm going to mark them, would be 4 and 6. They're on alternate sides of the transversal. They are interior the parallel lines. Also 5 and 3, angles 5 and 3 would be alternate interior angles. Now, if you understand that, then you'll understand what alternate exterior angles are because they're on the outside of the parallel lines. 1 and 2, 8 and 7 are exterior. And again, alternate meaning they're on opposite sides of the transversal. So 1 and 7 would be alternate exterior angles. 2 and 8 would be alternate exterior angles. Then we get to the same side interior, same side exterior. Again, aptly named. If they're same side and they're interior, we're talking about angle 4 and angle 5. And again, I'm not saying that they're congruent. I just want to keep saying that as I mark these. In fact, for sure, these are not congruent angles. But I'm just saying that these same side interior angles, 4 and 5 as a pair would qualify. Also 3 and 6. Okay, and then one more, same side exterior. If you understand what we said from the first, you're going to understand what these are too. And that is that same side exterior would be 1 and 8. Notice that 1 looks obtuse and 8 looks acute. So they're not congruent, but I'm just showing you that 2 and 7 as pairs, 1 and 8, like they say here, are same side exterior, 2 and 7 are as well. Okay, so with that in mind then, what would happen if we did in fact show that the lines are parallel? That's what this symbol is to show right here. This is saying that the lines are parallel, and there's a whole bunch that is true if the lines are parallel. These 5 postulate / theorems, we've got a postulate and 4 theorems, they correspond to the previous slide in the same order. Okay, so we had corresponding angles that we identified what they are. The corresponding angles postulate states that corresponding angles are congruent. This is the shorthand that we're going to use in proofs for this postulate. This says parallel lines implies, remember that from chapter 2, if then, that's the implies, like if A then B, could be written with an arrow and it's A arrow B, which means A implies B. That's what this arrow is. It's implies. parallel lines implies that corresponding angles are congruent. Parallel lines implies that corresponding angles are congruent. So what could we do? Well, what I just marked for you a minute ago when we didn't know they were parallel, now I can tell you that they are congruent. Because these lines are parallel, the parallel lines implies that why is that not working? 1 and 5 are congruent because they're corresponding angles. So if I were in a proof, and we're just about to start writing proofs, and I'm writing in a proof, won't let me go off the page, huh? Let me see if I can squeeze it. If I'm writing in a proof, and I say angle 1 is congruent to angle 5, congruent. Okay, angle 1 is congruent to angle 5. My justification for that is going to be this exact abbreviation. Parallel lines implies corresponding angles, and I just ran out of room. There's a S and a congruent symbol, okay, right there. All right, that's what we're trying to get across right now as we do this from the beginning, so that eventually we'll be able to write proofs using these theorems and postulates and not having to prove them each time. The theorems being things that you have to prove. Just the same, angle 2, y, okay. Angle 2 is congruent to angle 6, etc. Okay, so what we said again on the previous slide, as we just listed them for any picture that has potentially parallel lines in a transversal, now because we know those lines are in fact parallel, we're going to have some congruent angles. Angle 4 is congruent to angle 8, angle 3 is congruent to angle 7. This is because of the corresponding angles postulate, and this is the citation of that. By the way, we're going to give you a sheet, a half sheet of paper that lists the names of the theorems and their abbreviations, so you will not have to memorize this. You will be given on any quiz or test, and also with your homework, those abbreviations. Alternate interior angles are congruent. This says parallel lines implies alternate interior angles are congruent. That means that this angle and this angle are congruent. 4 and 6 are congruent. In a proof, we could say angle 4 is congruent to angle 6, and we would justify that with parallel lines implies alternate, or AIA congruent, right? Alternate interior angles are congruent. The next one is the alternate exterior angles theorem. I'll just use a different color here, which would prove that, for instance, angle 2 is congruent to angle 8. We could say angle 2 is congruent to angle 8, and this is the abbreviation you would use for that in a proof. And then finally, same side interior angles are supplementary, not congruent. Look at a pair of same side exterior angles. Same side interior angles, for example, angle 4 and angle 5 are same side interior angles. They are clearly not congruent, but what do you think is true about them? Well, they're supplementary, and we could prove this, and maybe we will prove a couple of these in class, or maybe I'll make another video, but we could prove this by showing that 1 and 4 are supplementary, 1 and 5 are congruent by corresponding angles, and then we could use substitution to substitute 5 in for 1 into the supplementary statement, and you would know that these are supplementary. This is how we would go about proving this. I may choose to do that with you in class. But anyway, I'm marking them differently now because I don't want you to think they're congruent. They're not, but they are supplementary. So we could write something like, and again, just so you know where this is going with the proof, you could write something like the measure of angle 4 plus the measure of angle 5 equals 180, and your justification would be parallel lines implies same side interior angles, again, I ran out of room, sum 180, okay? And then same side exterior angles are also supplementary. Let me just pick a different color again. And this angle and same side exterior angles, this angle and this one. So 2 and 7, for example, would be supplementary. They add up to 180. Okay, so let's do just a couple examples then. Here you can clearly see that line P and Q are not parallel. They did this on purpose because we want you to understand from the beginning that they don't have to be parallel in order to classify them a certain way. Here, angle 4 and angle 8 would be corresponding angles. Angle 3 and angle 6 would be same side exterior angles. I'm just picking them at random. Angle 1 and angle 8 would be same side interior angles. Angle 4 and angle 6 would be alternate exterior angles. Now, again, a minute ago we said the theorem said that parallel lines implies that alternate exterior angles are congruent. And 4 and 6 here are alternate exterior angles, but are they congruent? No, they're not congruent. In fact, it's pretty easy to see that angle 4 here is an obtuse angle, angle 6 is an acute angle, and that's because these two lines are not parallel. If they were, then yes, angle 4 and angle 6 would be congruent. This problem says identify which angles form a pair of same side interior angles with angle 1. Okay, so same side interior with angle 1, that'd be angle 8. Let's mark that. With angle 1, the one that would be same side interior with angle 1 would be angle 8, right? Identify which angle forms a pair of corresponding angles with angle 1. Corresponding angles with angle 1? Well, corresponding would be angle 5. And again, none of these are congruent because P and Q are not parallel. Here's an aerial view of an airport. This isn't the best question, but this is what they give us, so we'll just cover it real quick. They discuss the vertical, oh yeah, there it is. The vertical angle with angle 1. So here's angle 1, here's the angle that's vertical with it. They're asking us to classify that with angle 2. Now, do you see that? Let me draw it a little smaller. Here's the angle that's vertical with angle 1, this one that I'm coloring in. And then they're saying angle 2. Well, wouldn't those be alternate interior angles? You have a parallel lines and a transversal like this, okay? And then we're just going to roll ahead to one more example here. Stop the video if you need to. What do you think the measure of angle, the angle that's marked with angle A there, the lowercase a, what's that measure? Pause the video if you don't want to know the answer yet. It would be 65. The reason is that this angle 65 and this angle, they are alternate interior angles. And you see this, parallel lines? Parallel lines would imply that these alternate interior angles would be congruent. So A would be 65 degrees. A is 65 degrees. Just the same, C would be 40 degrees because this angle and this one are the same measure, okay? And then you could say the angle B is, what would it be, 75 degrees? And maybe you know something about triangles, but I'm not looking at the triangle. I'm looking at what we already know in geometry. We haven't discussed triangles yet. I'm looking at A, B, and C form a straight angle. So the three of them would have to add up to 180. I would not use the word supplementary here because supplementary technically deals with two angles, not three. But the three of them form a straight angle, which means they have to add up to 180. And it's 65, 40, and 75 that would add up to 180. By the way, this would be a great way to prove that the triangle angle sum is 180 as well, right? We will one day do that. All right, that's all. Thanks for watching.